Rectification is the process whereby we're converting alternating current into pulsating direct current. There are three methods in doing this. First is half-wave rectifiers. Now with a half-wave rectifier, or with all the rectification circuits, we use diodes because diodes have the ability whereby they can allow for conduction in one direction only. When we look at the half-wave rectifier, we will have a single diode with the anode and the cathode that will be connected to a load resistance, and we will supply this circuit with a sine wave. Now when we supply the positive half of the sine wave, this we would get from a transformer. When we get the positive half cycle of the sine wave, we will have a positive on the top there and a negative at the bottom. Now because we've got the positive on the anode, the diode wants to conduct, and as it wants to conduct, electrons can flow upwards through the resistor, and as a result on the output I would measure the positive half cycle of the input. When I go into the negative half cycle of my input sine wave, this polarity that's applied to the circuit now reverses. Because of that reversal of that polarity, I now have the negative on the anode, which means my diode cannot conduct. So for that negative half cycle of my input waveform, my output waveform will show 0 volts. That voltage we will see on the diode over there. Full wave rectification. With a full wave rectifier we need a special transformer, the center tapped transformer, and we're going to configure that transformer so that the secondary side of the coil has the center tap in the middle, and then what we have is our first diode like that and a second diode like that, which then combine together. That then feeds to my load resistance, and that then feeds back into my transformer. Now what we see with a transformer is the transformer across the top and the bottom will generate a sine wave when it is connected to a supply. So with a positive half cycle, the top will be positive and the negative will be at the bottom over there. Because it's center tap, these voltages are equal, and as a result that center point over there will have a 0 volt level on it. So when we look at this configuration, 0 is more negative, so that's where the electrons are going to come from. This diode is reverse biased, which means it will not conduct. So it will draw current through from this side, and then current will flow up through my resistor. The electrons will flow up through the resistor, and it will flow through my top diode, anode and cathode, because that diode is forward biased. That results in the positive half cycle just being transferred from the input side to the output side of my circuit. When I go into the negative half cycle, that polarity now reverses. So now that becomes negative and that becomes positive. That still remains 0 volts in the middle there, But now this diode has become forward biased and this diode has become reverse biased. So that diode is no longer connected. 0 volts is more negative than plus voltage. As a result, current's going to flow out from the 0 volts, again up through my resistor, up to that point and through my diode. As a result, the polarity of the negative half cycle has flipped over onto the positive side of my output. The bridge rectifier again is the bridge rectifier is fed from the secondary side of a transformer. Whenever we have this type of configuration of components, it's called a bridge. That point there feeds to the other side of my transformer input. This side over here feeds down. There it goes through my load, and then that feeds into there. So this is my output when this is my input. So now I've got, again, a positive half cycle. The positive half cycle, I've got positive at the top and negative at the bottom. With that positive on the top, this diode becomes forward biased. This one becomes reverse biased, so it can't conduct. This negative over here feeds in there. That reverse biases that diode and forward biases that diode. So the electrons are now going to flow from this side into the bottom, and it's going to flow up through this diode, out through there, and then it's going to flow upwards through the resistor, and it's going to flow to that point, and then it's going to return to the positive supply. So we get a upwards or a positive voltage on my load resistance. When I go into the negative half cycle, that becomes a negative, that becomes a positive. Now with that negative on that point over there, this diode will stop conducting and this one will start conducting. With this positive over here on that joint, that one becomes conductive, this one stops being conductive. So as a result, current's going to flow out from this side. The electrons are going to flow down through this diode, which is now forward biased. That diode is reverse biased, so current's going to flow out, and it's going to flow up again through the resistor, causing a positive pulse on the resistor. It's going to continue to that point. That diode is reverse biased, that one is forward biased, so current's going to flow through to the positive on that side, through like that. And that is how we convert alternating current into direct current. The two bottom circuits are full wave rectifiers because they rectify both the positive and the negative half cycle. The top circuit over here is a half wave rectifier because it only rectifies half of my input signal.